A very good morning, sir. I am Muhammad Hanif from CSCB section, and the topic given for my presentation is applications, advantages, and limitations of BST, that is binary search tree. Moving on to the outline of the presentation, by the end of this presentation, we will be able to know the applications of BST, the limitations of BST, and finally the advantages of BST binary search tree. Before going to the advantages, disadvantages, and applications, let us first know what is BST. A binary search tree, BST, is basically a type of data structure where the following properties must be true for any node X in the tree. The X node's left child and all of its descendants, children's children, and so on, have lower values than X value. For example, X is a root node, and all the other left childs should be less than that of root node, and the right child and all its descendants have higher values than X values. That is, the right childs all should be greater than the root node. Left and right subtrees must also be in binary search trees. See, for example, in the first level and second level, they are in binary search tree in the sense less than left side is less than root child and right child is also greater than root child. And in the third level, fourth level also, the binary search tree should be followed. And these properties make it faster to search, add, and delete values than a regular binary tree. Now let us know about the visualization of PST binary search tree. So here we could see root node is 40, and for example, if we need to search 35 number, we will first the 35 node comes to the root node and it checks if it is greater than 40 or not. Since it is less than 40, it moves to the left child. And here we have 30, and again now 35 is greater than 30. So it moves on to the right child, and hence we have found the 35th number. In a similar way, for example, if you want to search 60 number, first it traverses to the root node 40, and since 60 is greater than 40, it moves to the right child, and here it is 50. And again, if it is 60, then it moves to the right child, and hence the element is found. Now let us know the application of BST. One of the main applications of binary search tree is searching an element. The key feature of a BST is that it is a binary tree where each node has most number of two childs, and the value of each node is greater than all the values in its left subtree and less than all the values in the right subtree. And due to this property, BSTs allow for efficient searching by repeatedly dividing the search space in half, which makes it an important data structure in computer science and many other fields. So, when we take binary search tree, since it's already a binary tree, it will be having maximum of two childs or one child or no child. So, this makes it easier for searching any number of elements in wherever and whichever level it may be. And also, the left subtree of a node contains only nodes with keys lesser than the node's key. And right subtree, it's vice versa. And the left and right subtree must also be in a binary search. There must be no duplicate nodes. These points depict that root node is taken and all the other left childs are less than the root node, and all the right childs are greater than the root node. See, here we have another example demonstrated here. This is a binary search tree. And coming to this binary search tree, we have the root node as 8, and all the elements left side to the 8 are in binary search tree. In a sense, they are less than that of root node, and all the other nodes in present right as a right child are greater than the root child, that is 8. For example, if we need to check the seventh number of element, then it travels in the following way. It reaches to the root node 8, and since it is less than 8, it moves to left child, and here it is 3. Since 7 is greater than 3, it moves to the right child, and here we have 6, and again 7 is greater than 6, so it finally moves to the right child, and hence we have successfully found the 7th element. In this way, the binary searching works in binary search tree, and we could see here that there are no duplicate nodes, that is no repeating nodes also. Now let us talk about advantages of binary search tree. First advantage is efficient searching. In the sense, we will be able to search any element in the any level easily using searching technique in binary search tree. And ordered structure. Elements are stored in sorted order, making it easy to find the next and previous element. This point depicts that the elements are already in sorted order, that is in ascending order in the left side and descending order in the right side. No, in both sides it is ascending order. And dynamic insertion and deletion. Elements can be added or removed efficiently. This point depicts that we could add or insert very easily and efficiently. Moving on to the next point, balance structure. Balanced binary search trees maintain a logarithmic height, ensuring efficient operations. And the last point is space efficiency. The binary search trees store only the key values and which makes them space efficient. If we look into the linked list, there it maintains a node value and also the address of the previous node or next node. While in the case of binary search tree, it does not happen this way, which makes it more efficient in space. Here we have some more advantages of binary search tree. First point is when balanced, binary search tree is quick at insertion and deletion, which we have already discussed about this point. And binary search tree works efficiently because pointers and other data structures are not needed. It is efficient because it is merely stores the elements. In order to locate keys between n and m, n less than or equals to m, we may also perform range queries. In comparison to other data structures, BST code is straightforward. In the sense, it is in less number of code lines and it is easy to understand. That is, binary search trees code is easy to understand. It is straightforward. The items are always kept in a sorted sequence. In binary search tree automatically sorts them as they are needed. It is easily adaptable to enable different activities or to interpret data. It is adaptable as a result. And now we will be discussing about the limitations of binary search tree. Limitations are nothing but the disadvantages of binary search tree. It is not self-balancing. Unbalanced binary search trees can lead to poor performance. This point is like that. For example, if binary search tree is not unbalanced, that is, it's not in sorted order, then it fails in searching, insertion, deletion, whatever the operations it may be. And worst case, time complexity. In the worst case, if for example, if we need to search a node, like for example, node which is very in more number of levels, that is far away from the root node, then it takes large amount of time to search that element. So we could say that it is a worst case time complexity. And memory overhead. BSTs require additional memory to store pointers to chain nodes. Since the um, parent node stores the address of the chain nodes, here it is memory consumption is more here. And it is not suitable for large data sets. Limited functionality. The binary search trees only support searching, insertion, deletion. Rather than these operations, we cannot do the further operations. So we could say that they have limited operations and limited functionalities. Here we have some more limitations of BST. And the key drawback is that a balanced binary search tree needs to be implemented at all the times. Otherwise, it's possible that the cost of operations won't be logarithmic and will lead and result in linear array search. Since the time complexity for search, insert, and delete operations is big O, which is good for big data sets but slower than some other data structures like arrays or hash tables, they are not well suited for data structures that need to be accessed randomly. We have already discussed about these points in the last slide that time complexity is more for this. If it is big data sets, it would be good, and if it is small data sets, it takes some or more amount of time and compared to arrays or hash tables. The complexity of a binary search tree might rise if it becomes unbalanced or degenerates. Disable several operations that can be performed on ordered data structures. Applications of binary search tree. Here we have wide range of applications which we'll be discussing briefly about them. The first one is searching, which we have in detail the main application of BST in detail we have already discussed in the last slides. And sorting. Sorting a collection of elements in ascending or descending order. This point has also been explained in the previous slides that root nodes and tail nodes are arranged based upon an ascending order or descending order. Range queries. Finding elements within a specified range. Data storage. Storing and retrieving data in hierarchical manner. What is hierarchical manner? Hierarchical manner is nothing but child and parent, parent and child. These nodes are come under hierarchical manner. And databases. Indexing data for efficient retrieval. We could retrieval the data easily in binary search tree. and computer graphics representing spatial data entry. In the sense, this point says that it is easy in order to understand by just looking at the graphics. Artificial intelligence, decision trees, and rule-based systems. And it is also used in artificial intelligence these days. So these are the wide applications of binary search tree. By this, I conclude my session, and I hope I have demonstrated the applications, limitations, and advantages of binary search tree in a good manner. And thank you for your patience listening.